Hi, I'm Victor, and I'm here with a project of TEKS 7.11, Organisms and Environment, done by Pranav, Annie, Grant, and myself. And today we're going to talk about this particular TEKS. Thank you. Hi, today we're going to do an activity to better teach us how to use dichotomous keys, or keys to help us identify things. We have 3 simple examples using fish. There's a fish, and we're going to use a list of instructions to help us identify what it is. We start with step 1. If the fish shape is long and skinny, then go to step 2. If not, go to step 3. Since it is not long and skinny, we will go to step 3. If the fish has both eyes on top of the head, then go to step 4. If it has one eye on each side of the head, then go to step 5. We shall go to step 5. If fish has spots, go to step 6. If not, then go to step 7. It clearly has spots, so we shall go to step 6. Step 6. If fish has chin whiskers, it is a spotted goatfish. If fish does not have chin whiskers, it is a band-tailed puffer. Since it has chin whiskers, it is a spotted goatfish. And we have achieved our goal. That is example 1 of our dichotomous key activity. Off to example 2. Here is another fish. If fish shape is long and skinny, go to step 2. If not, go to step 3. It is long and skinny, so we'll go to step 2. If it has pointed fins, that is a trumpet fish, and it has smooth fins, it is a spotted moray eel. It has pointed fins, so it is a trumpet fish. That concludes example 2 of our activity. Now to the final step, example 3. Here is a new fish, and starting with step 1. If fish shape is long and skinny, go to step 2. If not, go to step 3. It is not long and skinny, so we will proceed to step 3. Step 3. If fish has both eyes on top of the head, then go to step 4. If fish has one eye on either side of the head, then go to step 5. Since it has one eye on either side of the head, we'll go to step 5. If fish has spots, go to step 6. If it doesn't, then go to step 7. It does not, so we'll go to step 7. If fish has stripes, go to step 8, and if it doesn't, it is a glossy weeper. It does not have stripes, so it is a glossy weeper. And that concludes the 3 examples of our dichotomous key. I hope now you will better know how to use a dichotomous key for the future. Here are 8 key vocab terms that you will probably need to know by the end of this presentation. The first one is natural selection. This is essentially survival of the fittest, or the idea that the stronger organism will better adapt to its environment and therefore live longer than the weaker one. The next one is evolution. This is a change in the gene pool of a population from generation to generation by such processes as mutation, natural selection, and genetic drift. The third one is an organism. This is a form of life considered as an entity, an animal, a plant, or a fungus. The fourth one is genetics. This is essentially just the science of heredity, dealing with resemblances and differences of related organisms resulting from the interaction of their genes and the environment. Fifth one, this is a very important one, is selective breeding. This is the process of breeding plants and animals for particular genetic traits. This is very popular in many scientific fields. Sixth one is species, the major subdivision of a genus or subgenus, regarded as the basic category of biological classification, composed of related individuals that resemble one another. The 7th one is population, the assemblage of a specific type of organism living in a given area. And the last one, but probably the most important, is a dichotomous key, which is what we just used in the previous activity to better learn how to use. The dichotomous key is a key used to identify a plant or animal in which each stage presents descriptions of 2 distinguishing characters with the direction to another stage in the key until the species is identified. Thank you. Those are 8 key vocab terms that you should probably know. Hi, now we're going to talk about some applications to real life that genetics have. Number 1, biogeneticists. or scientists who use selective breeding to create and adapt new organisms to better survive in its environment. Number 2, college professor. They can be teaching science of genetics to their students or be doing research about this very interesting topic. 3, scientist who can predict disease to give people early warning about a genetic problem. 4, genetic testing that can be used in court to test if someone is related to someone else. 5, can clear misconceptions about heredity, such as people used to believe that they were related by blood, but thanks to genetics, we know that they are actually related by DNA. Thank you, and those are 5 applications to real life that genetics have. Hi, I'm here now with 5 misconceptions about genetics and evolution. Number 1, organisms are always getting better through natural selection. That is a misconception because they aren't always getting better, but rather getting more adapted to their environment. 2, humans aren't animals. Humans are animals because they are in the class Mammalia and are primates like the apes. Number 3, evolution is only a theory and has never been observed. Evolution has actually been observed and documented for a course of over thousands of years. Number 4, identical twins have the exact same DNA. Although identical, twins are obviously extremely similar, their DNA have many minor differences. And the last one is natural selection always gives an organism what it needs to survive. This isn't true because it doesn't give anything, but rather reward organisms that adapt better to survive. Thank you, and those are 5 misconceptions about genetics and evolution. Thank you for joining me today while I talked about the 7.11 TEKS, organisms and environments. And don't forget that there's a file of 10 tax questions related to the TEKS. Thank you, and I hope you enjoyed watching my video.